Hi guys, this is Miss Chapel here. Today we are going to be learning Module 4, Lesson 13. We're going to continue talking about area, which is the space inside a shape. So our objective for today, or what we want to be able to do by the end, is to find areas by decomposing. That's going to be a big word for today's lesson. Into rectangles or completing composite figures to form rectangles. So let's talk a little bit about what that means. So first we're going to be doing something called finding the common product. So you're just going to follow along with me, whether that's on a blank piece of paper or if you have a whiteboard, just go ahead and write what I write. If you need to pause the video to catch up, that's fine. So the first thing we're going to do is we're going to practice our skip count of 4 and 8. So I'm going to start with my 4s over here. So I have, 4. So we're going to do a skip count by 4 until we get to 40. So go ahead and skip count that with me as you're writing. Here we go. 4, 8, 12. So we're writing up and down instead of side to side. 16, 20, 24, 28, 32, 36, and 40. Okay, now we're going to do the same thing but with our 8s. So we're going to go all the way up to 80 for this one. So we're just going to write it right next to it over here. So say it with me. We have 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. All right. So this is our skip count, but it is also called, these are called multiples. So we're skip counting or finding the multiples of these numbers. So we just found the multiples of 4 and 8. So now we're going to look at which ones they have in common. So we're going to draw a line to the ones that match. So here I see a 4. There's no 4 on this side, but there is an 8. So we're going to match the 8 to the 8. Let's look for another match. We have 16 and 16. We have 24 and 24, and we have 40 and 40. Now let's think about that. Why do we think those matched up? We have the numbers 8, 16, 24, and 40. So let's go ahead and 32. I just realized they both had 32 as well. So let's look at what these have in common. So we have, let's take the number 8, for example. Well, when we look at the 4s, the multiples of 4, what do we multiply by 4 to get 8? We multiply it by 2. So to get 8, we take 4 times 2, or 2 times 4. Okay, now then if we're looking at our 8s, what do we have to multiply to get 8? Just 1, because anything times 1 equals itself. So therefore, we can say that 4 times 2 is the same thing as 1 times 8. Okay, let's see about 16. Think about your 4s. How many 4s do you need to get to 16? Well, we have 1, 2, 3, 4. So 4 times 4 equals 16. What do you have to multiply 8 by to get 16? Well, let's use our skip count. 1, 2. So then that's the same as saying 4 times 4 equals 2 times 8. They both equal 16. Okay, now let's look at 24. See if you can figure out how many 4s we're going to multiply to get to 24. Okay, it would be 6. So we have 4 times 6. Now let's look at our 8s. How many 8s would we do? 1, 2, 3. So 3 times 8. Are we starting to see a pattern? Now let's look at 32. Okay, 32 is a tricky one. So to get to 32, we have to do 1, 2, 3, 4, 5, 6, 7, 8. So we're going to take 4 times 8. Okay, and then this one's kind of funny because then we'll do 1, 2, 3, 4 8s. So then it'll be 4 times 8 again, or you could do 8 times 4. That's the commutative property. Okay, let's do our last one, which is 40. What do we multiply 4 by to get 40? Well, we have 5. Whoops, not 5. Wrong one. What do we multiply by 4 to get 40? We multiply it by 10. So 4 times 10 is the same as, here's where I was getting the 5. 5 times 8. Okay, so all we're looking at here is we're finding the common products, the common multiples that 4 and 8 have in common. That'll be important for today's lesson. So good job following along. You can go ahead and erase if you're working on a whiteboard, or you can just move on to the next line if you're using a blank sheet of paper. All right, so now we're going to kind of break down what we're going to be doing in our lesson today. So we're going to, like I said, continue looking at the area of rectangles and other shapes. Okay, but as you can see, this looks different than the rectangles we've been doing so far. This doesn't look like a nice, perfect rectangle. So what it says here is we're going to add using the break apart strategy to find the area of a composite shape. Okay, so I want you to go ahead and draw this shape for me. So you have 1, 2, 3, 4 boxes going up. Then you're going to go over 2 and down 2. And then it's going to be 4 across, but you're going to leave this little square here blank. Okay, so it's eventually going to look like, whoops, not like that. It's going to look like something like this shape here. And then you can fill in the little boxes. So these lines. So go ahead and draw the shape on whatever you're using to follow along with me. Okay, so we have our shape, but it's not a very easy shape to find the area of. So what we're going to do is we're actually going to break the shape apart. So we're going to make a dotted line right at this point. Okay, because then if we look at it, it separates it in to 2 nicer shapes that we can find the area of. So that's what we're going to do. But first we need to find out what the different side lengths are. We can't find the area until we find the side lengths. So if we look at this side right here, how many boxes is that side equal to? 2. And it's the same up here, 2. So for this shape, we know that we're going to be taking 2 times 2 to find our area, which we know is 4. So we know the area of this shape up here at the top is 4. Now let's look at the one down here. Okay, if we look at this side here, there's 2 boxes, so that one is 2. Then if we look over here, we have 1, 2, 3, 4 boxes measuring along this side. So this would measure 4. Now keep in mind, we don't need to measure all of the side lengths because to find the area, we only need the length and the width. So for this shape, we would multiply 2 times 4, which we know equals 8. Now in order to find the area of the whole shape, we're going to add those together. So we have 4 and we have 8. So we're going to add 4 plus 8, which we know equals 12. So the area of this shape, we can't call it a rectangle because it's not a perfect rectangle. The area of this shape is 12 square units. We broke it apart into nicer shapes that were easier to find the area of, then we added them together. Okay, very good job. We're going to move on to the next part. Okay, now let's look at, so this is going to be the same shape that we just did, but I'm going to show you another way that you could have found the area, which was 12 square units. You could have found the area for the whole square. Okay, so this is just like the last shape we did, except they just added this part here. So you add that part in, okay, so now we're going to see that there's 4 going across, and 2, 3, 4 going down. Okay, so for that whole square, we're going to multiply 4 times 4, which is 16. Well, that's not the answer we found for this problem, but we also know that we need to take away this part here. And we know there's 1, 2, 3, 4 boxes, so we're going to take 16 minus 4 to get 12 square units. So really that was just another way that you could have found the area. You could have done it this way or that way, but it was the same shape. Okay, now let's look at another one. So this one's different. Okay, so what we're going to do here is we need to find out the area of this part of the shape. Okay, kind of that darker greenish blue part. So we need to find out what that area is, because we can use the 6 and the 6 to find out what the area is for the whole shape. And then we can also use the 4 and the 2 to find out what the area of the smaller rectangle is. But we don't have any information yet to find out what that darker shape, the area would be of that. So let's first find the area for the whole square. So like I said, we have a side measurement of 6 and 6. So this is a square because the length and the width are the same. So to start, we're going to take 6 times 6, which we know that if we skip count by 6 times, we would get 36. We're working in centimeters. Make sure you label your answer. So we have 36, but we're not done. Remember, we're not trying to find the area of the whole square. We're trying to find that darker shape, the area of that. So now we're going to find the area of this lighter, smaller shape. So we're going to take 2 times 4. So we're multiplying length times the width to get 8 centimeters. So we know that the whole square, the area is 36 centimeters. And then this little guy, the area is 8 centimeters. So how do you think we could find out what the area of this part of the shape is? We don't know what that area is. What do you think we could do with these two numbers, 36 and 8? We are going to subtract. So we're going to take 36 minus 8. And if I count back from 36 by 8, I would end up at 28. But make sure you label your answer. So it's 28 centimeters. So we found out that the whole square's area was 36 centimeters. The smaller rectangle was 8 centimeters. And then the dark green colored shape was 28 centimeters. Very good job with that one. All right, so this is the last one we're going to do. So what we're going to be doing, it says subtract to find the area of a composite shape with unknown side lengths. So what we're going to do here is we're missing some of our side lengths. We can't do our multiplication. We can't find our area unless we know the side lengths. But we can look at what we already know to help us fill in the other blanks. So let's look at this side up here, 11 feet. Okay, we also know that the side directly across from it should be just as long if it's a rectangle. So I know that so far I have 5 feet, but I need to get to 11 feet. How could I get from 5 feet to 11 feet? What could I add to 5? I could add 6. So the 6 and 5 together make 11. So I know that this side length here is 6. Now let's look at this side over here. We have 9 feet. Directly across from it, we should also have 9 feet, but it looks like it's broken down into 4 and another number. So we can add 4 plus another number to get 9, or we could take 9 minus 4 to get 5. Okay, so now we can figure out what the area is for each of the shapes because we know what the side lengths measure. So let's first find the area of the whole rectangle. So for that, we would take the side lengths 11 and 9. Ooh, that's a hard one. 11 times 9. That would equal 99 feet. Okay, now let's find the area of, well, I guess we'll look at these two. Let's find the area of the smaller rectangle. We would take 5 times 6, which equals 30 feet. Okay, so now can we figure out what the area is of this part of the shape, the kind of funny looking part of the shape? All we have to do, just like we did with the last problem, is subtract these two numbers. So we're going to take 99 minus 30. That one's kind of hard. We might need to actually write that in our standard algorithm. So I'm going to write that over here. Whoops, not 90. 99 minus 30. Thankfully, we won't have to do any borrowing, so it shouldn't take too long. So we're going to start in our ones place. 9 take away 0 is 9. 9 take away 3 is 6. So the area of the funky shape here would be 69 square feet. I might have forgotten that on a few of our last problems, guys, but always remember when we're talking about area, in the answer we have to put square in front of the units. So it's 69 square feet. Very good job. I know I'm going through this quickly, so if you need to, you can always go back and listen again or pause it if you need to get caught up. Let's see. Okay, that is where we're going to go ahead and stop. So you guys are going to go ahead and start on your problem set. So you guys did a great job following along. Like I said, go back and watch if you need further help.